Welcome to our third webinar in a three-part series. This one's called PD Data Management Fundamentals. So on my left here, or your right, I have Thomas White, our Senior Engineer at EA Technology from our field service team, and I am Brad Monaghan, the head of the service team. We're here in Brisbane, in Australia. The sun's shining. Nice day for the middle of winter.
It is quite nice.
Yeah, we haven't had the best weather lately, but today's a good day. So this is the third webinar in a three-part series. The first one was called PD Instruments. That was in November 2021, and that's where we took you through the UltraTev Plus 2 and all the pieces of kit that you can use to do online PD testing and how that all works. So if you want to go back and refresh your memory, that one's a good one to go back to, November 21. There'll be a link to that somewhere where you can find it. Then part 2 was PD data analysis. That was in March of this year. And that's where we went through how to analyze the data, how to figure out if you've got PD, and all those types of things for the technical detail of figuring that stuff out. And so today, what we're going to do is, how do you manage all of that data? What do you do with all that data? And how are you going to get the best results over time? Because you should, a really good plan is to have an active PD surveying project in place where you collect condition data of your assets and figure out how they're performing over time, whether they have PD or they don't have PD. But running the tests is a very important piece of the puzzle to asset management. So what we're going to go through today is we're going to go through, where does the data come from? So how do we capture the data? What does the data look like that we are talking about today? Why are we doing this? That's the overall question. Why are we going through the motions of doing all these activities? Data storage, how to trend that data, how to spot key trends within the data, and then how to prioritize assets, which ones to act on first, which ones are not as important on the list of priorities, which ones are high up on the list of priorities to focus your attention and money and time towards. We've got some case studies all the way through the whole presentation, and we've got questions. You guys can ask questions right now. They're on your little polling screen there. You should have a tab that says questions. You can type in any question you want at any time, and whoever's sitting there, which is Thomas right now, he will answer the questions and type them, and then we can talk about the questions as well if they're relevant to the whole group. So let's move on from there. Okay, so let's start at the start. Where does the data come from? Where is the data captured that we are talking about managing? So today we're talking about the data that's coming from the UltraTev Plus 2. So the UltraTev Plus 2, you can see in the top right-hand corner there, is the instrument, the handheld testing instrument that we use for online PD testing. So it can record data and place it all into folders that are manageable on the computer. There are many different tests that you can run with that one instrument. So first of all, one of the first ways we listen for PD is to listen for the sound that PD makes, so that the sound that sparks or arcing makes. So we can hear that with our own ears, and that's all well and good. If we can hear it with our own ears, that means it's at a high amplitude at that point in time. If you can hear it with your own ears, these ultrasonic sensors will be able to hear it, and they will be able to record it. They will be able to get a phase plot, and there is recording capabilities within the instrument and the accessories that will capture it. So we've got the airborne flexible microphone, this one here on the top. We've got the ultrasonic dish for doing outdoor assets or assets where you need some distance between yourself and the asset under test. And then you have the ultrasonic contact probe, and that's the one that listens through pieces of metal or similar to listen for PD activity on the inside of chambers. We use that where we don't have an air path through the chamber to where we would use this one. And then we have electromagnetic signals that we can capture. So the main test that we use for that is called the TEV test, and that's where we have a picture here of Thomas holding the TEV tester up against the outside of the switchboard. And we also can capture those electromagnetic signals with a HFCT sensor, which is this one down on the bottom left, where we're capturing PD signals bouncing up and down the cables. And we have UHF sensors. There's no photos of UHF sensors, but we have them that can be plugged into the test instrument. Okay, so what does the data look like that can be recorded? We have phase plots from all types of tests, and that's one of the key pieces of information in diagnosing what's going on. We have waveforms, we have histograms, we have sound files, and all of that gets packaged up, and at the moment that all gets opened up in a HTML format. Now, what are the key data points that we're going to analyze and that we're going to look at within our databases? So for ultrasonic testing, we're going to look at the phase resolved partial discharge patterns. That's one of the keys to figuring out whether you've got some real PD or whether you're just hearing some sort of noise caused by something that's within the room or within the area that you're testing for PD signals. So analysing that pattern is a key to figuring out what's going on. We can also hear the sound. That is a key piece of information. And then along with them, we have the amplitude in decibel microvolts that gets recorded by the instrument. The sensor that we are using is important to figure out what's going on as well, because that will help you diagnose whether it's what sort of medium you're listening through. And there's also an algorithm within the instrument that can help you figure out what it thinks is PD or not. And then for the TEV and the HFCT and for the UHF testing as well, we've got phase resolved partial discharge patterns. That is a key to figuring out what is going on, whether you've got PD or not. Along with that, again, we have our amplitudes, our pulses per cycle. We can take background readings and compare to that. Are signals coming from other places or are they local to our switchboards or the asset under test? And we have interpretations. So within the instrument, it will give its opinion on what it thinks it is based on the decibels and the pulses as well. So the key here is the phase resolved partial discharge patterns and figuring out what they are telling us. So that's where we get our data from. The instrument's able to record it. We're able to do full surveys and many pieces of information come through. So now I'm going to hand over to Thomas to talk about how we manage that data, how it's done right now, and then also what the future holds as well for the data management. So this is Thomas.
Thank you.
Go for it, mate.
We have had a couple of questions come through just about quite specific testing methods. We will try to get to you. It's just today it was less about the physical testing and data analysis and more to handle the data. So we may get back to you just after the webinar with the more specific questions about testing. So one of the most important questions is, why are we doing this? And by this I mean, why are we trying to get long-term data trending and data management going? What are the benefits of this? So one of the ways that the UltraTev Plus 2 can be used and PD in general can be used is for quite quick short-term planning. And what that is you go out, you do your PD testing, you identify problems on the network, and you analyze them and do the repair and remove that defect from your network. One of the things that is really good for is your high level and high critical assets when you're if there are any problems, they need to be removed instantly. This is a really good starting place for a lot of companies when you first introduce PD testing into your testing regime, and you're getting rid of all the things that could lead to failure quite quickly. What we are aiming for with the data management systems and the trending is being able to focus more on long-term planning. So finding the problems that aren't just need to be fixed immediately, but they can be trended, they can be put into secondary jobs, and we can manage them over their entire lifespan rather than very quickly acting on them immediately. So once you start to go into data management and trending, we start to be looking at not just the high level PD sources, but also the low and the medium. You're looking at not just what the PD is degrading, but also, is there a future project coming up on this asset that we can hold out and do the works together? Is it an asset that can't be turned off? Is it something that we need to plan further down the future? It's not only used for the planning of maintenance, but it can also be used for something like extending the life of an asset. If you have an asset such as a switchboard that is coming up to end of life and you've been doing really good PD testing and you've been showing that it hasn't got any defects on the board, Can you use this data to justify extending the life of that asset and saving money on the asset replacement? So all of these things need to be worked together, and by having good quality data and by being able to store that data effectively and trend it effectively, you can really make better quality decisions for the life of your asset. And the overall goal of that is you're moving from being reactive in your maintenance to proactive. You start to a lot more targeted maintenance, and you're only doing work when it is needed compared to reacting to failures or reacting to very high level PD sources. Another really good thing about the data management projects is you can start to look into your population type issues. What you will find is there are some PD defects that will crop up time and time again on the same assets. So by keeping good data and by being able to trend that data, we're actually able to identify that problem, and we can then act on it across an entire population rather than only acting on individual assets one at a time. So in terms of data storage and trending, there are a couple of different ways that companies go about it. The first method is actually what Brad and I do on our day-to-day basis, and historically it's what we have done using the UltraTev Plus 2 device. What we have is the full option of the PD trending, and that's what using the inbuilt features of the UltraTev Plus 2. So you can go through, you can record everything on site, and you use the inbuilt functionality to trend that data. The only problem with this method is it involves manual trending. You cannot easily check between if a PD source is growing between different surveys without manually looking at all of the data. This method also doesn't easily integrate with your systems and the forms that a lot of companies use to trend this on their internal networks. The only other problem that comes with it is it does require a high amount of user knowledge, and that's what we do a lot of our time training with our clients on. So this method does rely on the person in the field knowing how to use the device, but also how to test specific types of HV assets, what test types are useful on different types of switchgear, as also what test methods are useful to find different defects. Whilst it is a very effective way of trending the gear, it is something that we've been actively working on improving over the years. Something that a lot of our clients do is they try to integrate this PD into their own company forms. And what that does require is a summarization of the PD data into more general data points. Now, a lot of our companies will summarize it into the amplitudes of the PD sources or the pulses per cycle in terms of TEV, or even the interpretations that are built into the Plus 2. The only problem with this is, as Brad talked about earlier, our most critical analysis tool is the phase resolve partial discharge pattern. And traditionally, without taking photos and uploading it into the devices specifically, it can be very difficult to get that analysis tool into company integrated forms. So what we have found is that it requires a lot more knowledge from your technicians in the field, from the people taking the data. If they are summarizing the PD data poorly, or they are confusing noise for genuine PD, there is no way of differentiating that from purely the amplitude numbers alone. And it can require multiple site visits then to weed out and come to the final conclusion. So the third option is something that we have been working on in the company, and it is a full end-to-end solution to take that from the inception and the creation of what all the substations you would like tested are, what the tests you need taken are, and then what goes on in the field. So this is something that EA are calling our managed surveys, and it's part of our latest firmware upgrade on the UltraTev Plus 2 device. And it is all about consistency across the board, from consistency in the planning of your substations and what measurements need to be taken, as well as the consistency of data capture in the field in order to provide the best quality data to be analysed back in the office. All of this is a fully configurable system where you can design your substations in a cloud-based system. Those substations can then have individual test regimes allocated to them, and you can design exactly how you would like each substation tested. This data is then used and it is assigned to a specific person or a specific +2 device. The data is then downloaded to that device, and the user is stepped through the full survey analysis in what we're calling a guided mode, where it takes them through every single test that you have asked to be completed, and then that data is automatically uploaded back to the cloud by connecting the +2 device onto the internet. These are a couple of screenshots of what you would be looking at, and it's the design of the full solution, all the way from you create your work orders and your substations on the cloud, download it to the +2, and then steps it through in the guided mode. All of the data captured on the device in the exact same way as the traditional PD survey functionality is uploaded to the cloud automatically, where it can be edited if something is wrong, and it can be proofed before going into a full trending over the years. One of the most powerful features of this is the consistency of the data and the automatic trending that takes place on the cloud. So now if you have taken multiple readings across multiple years, you can actually compare all of those readings quickly and easily, all in the one place and on the one screen, rather than jumping between all of the different survey files, which we've done traditionally in the past. So this is a really great tool that not only allows us to capture and grade things based on the amplitudes, but keeps all of the phase plot and audio file data that we use for more in-depth analysis and decision making. So once you do have all this data and all of it has come back for analysis, how do we start to spot key trends that are appearing across our assets? And there's a couple of ways to look at it. And the first one you need to look at is looking at key trends on a single asset. And the biggest thing we can talk about on singular assets is you want to make sure you're trending genuine PD and not noise. We work with a lot of clients who put a lot of effort into tracking what we've later turned out to be noise, if it's caused by some sort of electromagnetic or ultrasonic interference that they've been trending over the years. And it is something that we try to get away from by using the partial discharge patterns and by confirming something is PD before you go down the path of trending it. So once you have identified something as a genuine PD source, what can we trend? And for TEV signals and the HFCT signals, there are very trendable things. Usually things like amplitude and your pulses per cycle are trendable, and it is all, you can keep an eye on it and it should increase in amplitude as it moves towards failure. Ultrasonic amplitude, on the other hand, is something that we do know does not necessarily have to increase in amplitude as it moves towards failure. So that's something you really have to take into account for when you are dealing with these different types of PD defects. There are a number of different things that can also change the levels of PD defects over time. And some PD defects can be affected by loading. It's very common for other ultrasonic defects to be affected by the humidity. And other network events can have a very big role on how this PD defect is behaving over time. So the biggest part with that is data quality is key. The more data that you do have on these defects is something that is really critical when you're trying to trend them over a longer period of time. The other one is the more data you have is very critical. If you're not finding PD and you're just doing general sweeps of your assets, traditionally we would recommend yearly testing for all of your HV assets. If you are starting to find PD problems, you're looking to trend and keep an eye on them, one thing you can do is increase that testing interval down to 3 or 6 months or whatever works best based on criticality. But you can also start to do full-time monitoring if an asset is deemed critical or the PD defect is high enough to warrant it. So what we have here is a single PD defect that we've found that change this activity based on the load going of the switchboard. So what you have in the bottom is a graph of our ultra TEV monitor, which is looking at 2-minute data of the amplitude of a TEV-based PD source in a pitch-filled cable box. So what we were finding is that there was daily activity occurring, switching on and switching off with the load of that feeder. And as you can see from that picture, it was actually only active during daylight hours, Monday to Friday, switching off on weekends. But also the second Friday there was a public holiday in Australia and there was no load on the board. So this is just the type of testing of it can shift and it can go up and down. So managing that source required the monitoring system in order to effectively trend that data. Over time, we were able to see it moving up and down, and we were able to eventually do some works and remove this PD source from the network. But trending of an individual asset and its behavior with different factors is a really critical part of deciding the maintenance regime for it. But once you move away from a single asset, you'll start to notice that you do get key PD defects appearing again and again on multiple assets across your network. And sometimes it's very obvious. You'll see some things like design and manufacturing defects, which will not only be similar in nature and construction, but will also give you a very similar phase resolve pattern. And it's almost identifiable across the entire fleet of the assets. What you'll see time and time again is some workmanship issues, and they are things like you can see on the bottom left, where it's a trifurcation with an extra piece of heat shrink put into an unscreened portion. And again, that will come back to staff training and are they understanding the ramifications of small changes. We've also seen things like environmental issues, like you'll start to pick up of are some assets not suited for the environment they are in. And what you have to be sure is that whatever method of data analysis and trending you're doing, is it capable of giving you the data in the analysis process for you to pick up on these types of trends? Specifically, the UltraTev Plus 2 and the method that Brad and I use, we always make sure to record things like your environmental readings, your temperature and humidity on site at the day of test. We record your manufacturer of the asset, the type of asset it is. So when we come back, we can compare to other assets of the same type and see if these issues are cropping up either other places in the same network or even other places in the world. So here's just a bit of an example of a long-term asset that is a PD issue that we've found, and it was how they managed it across. So this is part of the 11 kV Ray-Roll LMT switchboard, and there is a known defect in the CTs of these boards caused by air bubbles during the manufacturing process. What this gives off is very high level TEV signals, and we've seen these on a very large percentage of the Ray-Roll LMT CTs, and they tend to swamp the entire switch room when doing the testing. But for this particular client, we did identify the problem and we did research, and what we found was there was a relatively low failure rate on the CTs. So we worked with that client, and rather than doing a large scale replacement of all the CTs, they opted for quite close monitoring of all of the issues. Whilst they were high level, they were less likely to go to failure quickly, and monitoring was a very viable option until they could plan the full works to get them out. What the defect itself looks like. So when you did do an inspection of this board, all you are seeing is the outer resin. There was no visible defect. However, EA Technology had previously done forensic analysis of these CTs, and we knew exactly where the defect was likely coming from. On the contrary to that, here is a type of defect where it was originally identified during an inspection. So what they found is that there was a manufacturing defect on the fuse canister, and you can see that in the bottom picture there with the signs of degradation. So they found this, and then they went through and they identified that this defect could be found using PD, both ultrasonic and using the TEV method. They then went out, figured out how many of these assets they had in the network that were likely to have the same, and started to do a PD program where they sweeped all of the assets. What they found is that it was cropping up on a large percentage of the other assets from the same manufacturer and same model of gear. This particular problem, they were less worried about the exact defect itself, but the degradation caused by the ozone and the nitric acid buildup causing problems on other parts of the gear, which you can see in the top right image. So this is a problem where it was significantly lower level, but the forensic breakdown that they'd done and the information they gathered during this analysis allowed them to make good decisions, and by finding all of the other ones, they could do the repairs before it necessarily reached this level of degradation, but they had to manage the entire population as a whole. So I'll hand back to Brad Monaghan to go through which types of defects should we prioritise first.
Yep. There's no current questions. Awesome. Yep. Okay, so how to prioritise, which defects should we act on first? Let's go through this. Okay, so risk comes down to risk. So where the defect is, the more we understand about it, and then the amount of risk that it is posing on that portion of the network is a big factor into figuring out what we want to do about it. So does it pose a safety risk to your workers, to the general public, people that are going to be nearby? Does it pose a financial risk to your company? Does it give you a production or an operational risk? Usually productions for your companies that make things, and operationals usually for companies that supply electricity. So what we recommend, hang on, I'll just turn my laser pointer on here. What we recommend is, once we've gone out, scanned a whole bunch of assets, all this data's come back to us. What are we going to put our effort into? And we recommend focusing on contact corona or surface tracking type PD sources that are within high voltage chambers first. And the reasons for that is because those types of defects will be doing ongoing damage inside that chamber, and that's because of the ozone gas that's being generated while PD is occurring. So you can have a failure within that chamber, the ozone gas can seep through to other chambers to start degrading those chambers, and generally these are found by ultrasonic testing. So that's where we have the ultrasonic probe and we listen into the chambers. From there, we will focus on the highest amplitudes first. And what we want to do for ultrasonic or problems that are found by ultrasonic testing is we shut them down and inspect them. When we do that, it might be an easy fix. You might have found something that's very easy to fix. You might be able to just increase the clearances, make a construction change, clean the whole area up, turn it all back on, and keep a very close eye on it for the next couple of years to see if PD will return. But it might be an easy fix. And then vice versa that, you might open it up and it could be very, very close to failure, depending on the amount of degradation that's occurred. Now, both of those things are very important to do. If you can get something and pick it up very early on in its life cycle, you've got yourself an easy fix and you've taken a defect on the network, and it justifies what you're doing. And also, it goes to show if you've prevented a failure and something that's very close to failure, you've done the exact same thing, but towards the end of that life. Now, ultrasonic sources are difficult to trend. They may not increase in amplitude as it leads towards failure. That's because it's heavily dependent on, or they can be dependent on, the humidity within that chamber. And it's also got to do with how much distance do you have left on your insulation before you're going to get a flashover, either phase to phase or phase to earth. Now, internal void PD sources, these are the ones where you've got the defect on the inside of the insulation. Generally picked up by the TEV test technique. You can pick them up with the HFCTs as well. Now, these ones tend to be trendable most of the time, so they can get worse and worse and worse before they fail. But these are more difficult to localize, however. So as you can imagine, the signals from these PD sources travel through all the conductors around them and all the metalwork away from their source. So for you to fully track them down and locate it to an individual component can be a difficult thing to do. That's where we do sectionalizing. We can introduce offline PD testing. If you think it might be within an oil-filled chamber, we can do oil tests such as a transformer or an oil-filled ring main unit. These are the types of things we can do to figure out where they're coming from. Usually a visual inspection won't reveal the defect. As Thomas brought up that slide before, he showed the CTs what they look like on the outside. They look perfect. And then when you cut one in half, you see this big internal void type defect within it, where sparks have been jumping across a gap for a long time. Now, the longevity of these PD sources is usually highly dependent on the location of the source and what insulation it's trying to eat through. So what I'm really saying there is, how long have you got before something's going to fail? How long before it's got to blow up? Internal void PD sources can last longer, but it depends heavily on where it is. So if it's inside a cast resin CT, as Thomas's example before, that can discharge for years and years and years and even decades. And it's just that the sparks don't have enough energy to eat through that insulation because it's such a hard insulation. But if it's trying to eat through an XLPE cable or something that's an insulation that's quite rubbery and malleable, it won't last as long because the heat from those sparks will burn a track through that and cause it to fail. Now, another big factor when we're comparing PD sources is the age of the PD source. And what I'm talking about there is, how long has that PD source been active? Is it a brand new source? Like, is it a brand new piece of switchgear? You've just built it, it's discharging from day one. That's probably a very important thing that you want to get on top of and figure out what it is, because you haven't trended that for any amount of time and figured out whether you know it's going to fail or not. Whereas if you go out and do a benchmark survey of all your assets, you'll find some PD sources, and they may have been there for a long, 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 long time. So those ones there are probably going to last a long time as well, maybe, depending on where they are and depending if maybe they've just started. You don't actually know. So that's why trending, capturing really good data, testing correctly, and managing those assets is an important factor there. Okay. So what's changed? Usually a PD source will kick off because something's changed. There's either been a network event, lightning strikes, switching in the area, something like that. Has there been recent works at that asset in terms of, have people got their hands in there? Have human beings got involved? Has there been a shutdown? Have they left their spanner in there? Have they moved the HV cables closer together? Have they left an earth wire? Have they kicked off? We had one the other day where a worker had got into a switchboard and accidentally kicked off an earth lead, and that earth lead was then resting across all the bushings. And they knew exactly how long it had been there, and they knew very likely who had kicked it off, but that was discharging. And if you left that there long enough, that would have failed. So keeping on top of things. And that's why it's important to test things when they're brand new and when a change has been made to them. So if you go in there and make a physical HV change, figure out whether they've left PD in there, and then compare all that to previous results. So that's how we compare our PD sources to figure out where we're going to focus our assets. Our asset allocation to figure out where we're going to spend our money and our time. Now, when we've got a population issue, so just say you've got a problem on one type of ring main unit or one type of switchboard, and then you go, right, well, maybe we've got more of this. So you go out and scan all 100 switchboards that you have, and you find a problem in 30 of them. What are you going to do about that? So what we need to know, knowledge is power in that instance. Understand the failure mode. So what you want to try and do is figure out what is the root cause of the population defect. Also, what is the ideal way to find the problem? So is the ideal way using an Ultratec +2 and scanning for partial discharge in that area? And it usually is for us because that's what we specialize in here. And then you may want to do a forensic analysis on one of those defects. So just say you had 30 ring main units out in the field, pick the worst one or pick the most critical one, take it out of service, replace it, get that part of the network repaired, and then take that asset back to a lab or some sort of area where you can strip it down and figure out what the root cause is. Was it a manufacturing defect? Was it an installation defect? Was it, has something happened to it recently? They're all the questions that are going to go through your head. So how many do you have on the network? How long have they been discharging for? Have you had any failures as well? Sometimes you'll find PD sources that have sat there for a long time and you haven't had any failures. So how much risk is that posing to your network? Or maybe you've got some and they have failed and you didn't think they were that bad a problem. And those are going to be, they're going to have a high risk at that point because you've got some case studies of those failures on that network. So you want to allocate some assets there. And can they be replaced? How many spares do you have? All that type of stuff. What level of risk is acceptable for your network and for those assets in that location? And then what you want to do is you want to protect yourself from PD defects in the future by planning for the future. If we're going to keep building this type of switchboard in this type of environment with these type of installation techniques, are we going to get PD? So what you can do is prevent PD from the beginning, and that can go back to the procurement stage. What are you buying? What are you installing? Because they can have problems from the from when you bought them. The design of the asset, the installation practices that all the people in the field are using to build the asset, how are they transporting it to site? Are they following all the installation instructions, especially on the cable terminations, that type of thing? When they get in and do maintenance, are they doing correct maintenance? Is it advised maintenance? Are they using the right greases? Are they using the right, mechanical components, electrical tests, all those types of things? And a lot of that comes down to training and awareness of all your staff that are involved. So that's how we recommend that you manage a population issue. But capturing all the data in the first place is going to tell you whether you've got a population issue. Also, if you're having failures, you're gonna know that you've got a population issue, but you may have problems out there that you don't know of until you go out there and test them and inspect them. Okay, so we're going towards the end of our presentation now. So this is the summary page. So managing data is the key in moving from reactive to proactive management of your assets. So what you want to do is get out there and collect good quality data, and then get that data and do something with it. Put it all in a place where it can all be viewed in the one spot and trended over time. That data can be used for immediate works because you will find problems straight away that you need to do things about. But once you've replaced that, test it again, see if you fix the problem. So that is managing that asset well. It can be used to justify projects. So there may be a switchboard out there that you thought had a lot of problems and you can't find any problems. So what we can do there is extend the life of that asset. Or you may have a switchboard that you didn't think you had any problems and it's got a lot of problems. So that will justify bringing forward a project, bringing forward the replacement of that asset. That all goes into your long-term planning, also short-term and medium-term planning. This data can be used for justifications as well. So just say you had 40 ring main units out in the real world. They're not due for replacement just based on age until 20 years time, but you're having problems with them and they're posing a risk to your network. So you may need to bring that forward because of the condition data that you're capturing here, and you can justify that because all the condition data is within your database. Now, another important thing is to trend PD data, not noise. So what can happen, as Thomas said earlier, is every time you run a test, you're going to get an amplitude. So as an example, if we run a TEV test, we're going to get a decibel count and a pulse per cycle count. And the bulk of the time, that's just going to be some sort of background noise. And it can be high level background noise where it's not a PD issue. But if we're constantly looking at those numbers and going, oh, we need to focus our attention there, we're not analysing it correctly, and we're not focusing the attention on the important bits of information, which is a lot of it's got to do with the phase plots. Same with the ultrasonic test. You can get your ultrasonic listening device. You'll always get an amplitude because you're running a test. You're going to be hearing sound, and you can get big levels of background sound, but you don't want to trend that. You want to focus on what's real, put your attention on that, and trend those pieces of information. Now, capture the best data possible. Better data equals better decisions. So with the new managed surveys cloud software, you can control where the people in the field are taking their tests. So as Thomas said before, you'll design a switchboard, you'll design the work that you want conducted on that switchboard, and what that means is where do you want them to take a TEV reading? Where do you want them to take an ultrasonic reading? where do you want them to take a cable PD reading, a HFCT reading. Then that is controlled back in the office. That gets the worker in the morning, turns on his Ultratev +2, puts it onto the Wi-Fi, and the internet will give him basically the surveys that you want them to perform. Then they go out in the field, they go to those substations or ring main units, wherever they are, pad mounts, outdoor yards, and they get walks through, take a TEV reading here, take an ultrasonic reading here, and all that data gets captured by the person in the field. They just have to know how to capture the data and use the +2. Then at the end of the day, they put their instrument back on the internet. It uploads all the data back to the cloud where you can analyze it, trend it, compare it to other things, and there's a lot less handling of the data. Okay, and then we want to assess the risk of each of the PD defects on your network. And that is obviously a big fundamental of what we're trying to do here. Now that is the end of the presentation. So everyone will get sent within the next 24 hours a link with the recording of this, the slide deck that we just went through now, or the video of the slide deck, I should say. Have we got any questions now, Thomas?
Yep, so we have got a couple of questions just asking for a little bit more information about the online managed surveys option. We didn't have too much time today to go through it. We had a lot we did want to cover, but if people are interested in getting something dedicated to it with full demonstrations, you can either get on to us, we can show you, or we are considering running a webinar dedicated purely to that.
Yeah.
So if you do let us know you are interested, we can run that type of things. We're just trying to keep these webinars to be more educational and very short and sharp in what the details we are going through.
Yeah, we can run through, it's best for that one to run through like a live thing where
we get live demonstration.
We get the cloud up, we show all the buttons, we show what everything does, because there are a few buttons and a few different ways to set everything up, and then we can do it live down to a +2 and see the final asset of it, the final product of it as well. Any other questions there, Tomo?
No, we've kind of got answered all of them in details. If anyone does have any questions, please feel free to send them through.
Yep. All our details are on the page here.
Yep. No, just a thank you.
No, that's all right. Well, thank you everyone for coming. If no one's got any questions right now, there's our emails and you can shoot them through or get in contact with our office here. And thank you very much for coming along today.
Thank you.